All right, everybody, get ready, because today we are diving deep
Yeah.
into PHP PDO transactions.
Yeah.
We're talking way less, what even is this, and a lot more, oh, that's how I keep my database from going crazy. So, like, if you've got that tech interview looming or you're up to your eyeballs in some coding project, this stuff is pure gold, trust me.
Couldn't agree more. Knowing this stuff, it's the difference between just crossing your fingers and knowing your code's going to handle anything you throw at it. Let me tell you, databases, they don't mess around when something goes wrong.
Which is why the guide we're looking at today is so awesome. It lays out this whole transaction thing in a way that finally makes it click. We're not talking memorizing code like robots. We're going for actual understanding this time.
Because once you get that why, it's like having superpowers.
Yeah.
Being able to see right through your code. You start spotting issues before they even become problems, and suddenly you're building stuff that's, well, rock solid.
Music to any coder's ears, right? So before we get fancy, let's start with the basics. What is a transaction, really? Our source today calls it a safety net, but in my head, it's more like, a giant undo button for your whole database. Am I on the right track?
You're getting warm. It's all about making sure a whole bunch of database actions, things like adding info, changing records, you name it all, get treated as one big unbreakable unit, meaning either everything works perfectly, or if even one tiny part fails, boom, the whole thing rewinds like nothing ever happened.
Gotcha. So it's all or nothing makes sense. But why is that so crucial? Can you give me an example of what could go totally wrong without this whole atomic approach?
Picture this. You're building an online store, right? Someone's checking out with a shopping cart full of goodies. Your system's got to do a bunch of things at once. Update their order, make sure the items aren't in stock anymore, and take their payment. Now, imagine if, for whatever reason, that payment part glitches out.
Uh-oh. It sounds like a recipe for a major headache.
You said it. Without transactions, you could end up with the order marked as good to go, those items gone from inventory, but whoops, no money actually collected. Talk about a disaster waiting to happen.
Oof, that's rough. Now I really see how transactions would stop that nightmare scenario dead in its tracks.
Bingo. It's all about keeping your data squeaky clean, which is like rule number one for any app dealing with sensitive info. And that's where our friend PHP PDO steps into the ring. Think of PDO, short for PHP data objects, as this bridge between your code and whatever database you're working with.
So it's kind of like a translator, making sure those two can actually have a conversation.
Precisely.
PDO gives you this standardized way to talk to all kinds of different database systems and transactions. Those are one of its most powerful tools. The article we're looking at, it highlights three main commands for making this magic happen: beginTransaction, commit, and rollback.
All right, let's break those down one by one. beginTransaction, if I'm remembering this right, is basically like slapping that big red record button before you go and make a bunch of changes. Yeah, you nailed it. That's your signal to the database saying, hey, everything I'm about to do, consider it part of this one big transaction. Then comes commit, which is your way of saying, all right, everything went perfectly.
So assuming every single database operation within that transaction does its job, commit, takes all those changes and makes them official, permanent, right? But hold on, what if something blows up along the way? That's where rollback comes in to save the day, I'm guessing.
You got it. Imagine you're trying to take money out of a user's account, but there's a glitch. Maybe their balance is too low or something.
Yeah.
Rollback is like that big red emergency button that instantly undoes every change made during that transaction, making sure your database doesn't end up a total mess.
I can see how this would save a developer a whole lot of sleepless nights, that's for sure. The article also talks a lot about how important error handling is within these transactions, specifically using this try-catch structure. What's that all about?
Think of it like setting up a backup safety net, just in case. It lets you plan for things going wrong and handle them gracefully instead of having your whole system fall apart. You try to execute your code within a transaction, and if anything goes haywire, the catch block is there to intercept it before it becomes a bigger problem.
So it's like having a solid plan B in case plan A goes completely sideways. I can dig it. Now, the article gives this really helpful example using, get this, student grades to show how transactions work in the real world. Want to walk us through that one?
Absolutely. Let's say you need to update the grades for a whole bunch of students who just took a big exam, right? You could write separate update statements for every single one. But here's the problem. What if something, anything, interrupts that process halfway through? Well, without transactions, you're basically playing Russian roulette with those grades. Some might get updated, some might not. Total chaos, right? Transactions make sure it's either all the grades update properly or none of them do, keeping things nice and consistent.
Okay, now that picture is crystal clear. It's like that all or nothing thing prevents some poor student from getting their hopes up for nothing while everyone else is celebrating.
Exactly. And hey, speaking of keeping things safe and consistent, the article also dives into this really important concept, prepared statements. Remember how we were talking about those earlier, about how they're like this super safe, super efficient way to talk to your database? Well, it turns out they're also crucial for locking down your transactions.
Right. I'm starting to think those prepared statements deserve their own deep dive sometime soon. But for now, can you give us the quick and dirty on how they boost security, especially when we're dealing with transactions?
You got it. So imagine you've got some user input, maybe a student's new grade, and you're using that to update your database, all wrapped up in a nice, safe transaction. Sounds good so far, right?
Right.
But what if, and this is where things get scary, what if that user input has some sneaky code hidden in it, something designed to mess with your database? This, my friend, is the dreaded SQL injection attack.
Oh, yeah, I've heard whispers of SQL injection. It's like the boogeyman of database security, always lurking in the shadows.
It's a real threat, for sure, but prepared statements are like this bulletproof vest for your code. They basically create a barrier between the data you're sending to the database and those SQL commands themselves, making it almost impossible for any malicious code to sneak through and hijack your database operations.
Okay, that's a huge relief. So even with the protection of a transaction, prepared statements add that extra layer of defense against those nasty SQL injection attempts, kind of like double bagging it, just to be safe.
Exactly. Now, one thing I appreciate about this article, it doesn't shy away from the trickier parts of transactions either. Like, remember how we talked about DDL queries being the exception to the undo rule?
Right. Those DDL queries, they're the ones that actually change the structure of your database, not just the data living inside. It's like, I don't know, remodeling your whole house versus just moving the furniture around, right? But I gotta admit, the article kind of glossed over why they're different in this context.
It's one of those things that trips up a lot of developers, especially those who are new to the whole transaction game. So let's clear that up right now. Imagine you're using a DDL statement, something like, oh, drop table, super dangerous stuff inside of a transaction. Now, let's say later on you realize, wait, I messed up, and try to use rollback to undo what you did.
You're stuck, aren't you? No going back.
You hit the nail on the head. Once you've dropped a table with a DDL statement, it's gone for good, transaction or no transaction. It's a harsh lesson, but it just goes to show how crucial it is to really understand what those different SQL commands are doing, especially when you're working with transactions.
That's a great point. Transactions are powerful, but they're not a free pass to throw caution to the wind. And speaking of caution, our article also calls out a few common pitfalls to watch out for, right?
Exactly. Like any powerful tool, you got to know how to handle transactions with care, or you're going to have a bad time. The first pitfall they highlight, long-running transactions, something to avoid at all costs.
Okay, that one makes sense. Even just thinking about it, the longer a transaction is hanging out, the more chance something's going to go wrong. But can you unpack that a bit? Why are those long-running transactions such a problem?
Sure. Let's say you've got a transaction that's holding on to a database lock while a customer is browsing your online store.
Right.
Right. No big deal. That's how it should work. But what happens when that customer tries to check out, but that same transaction is still chugging along in the background?
I'm starting to see the issue here. If it's a long-running transaction, it could block other users or even other parts of your system from getting to the data they need, right?
Exactly. And worst case scenario, you end up with what we call a deadlock. Imagine a massive traffic jam, but for your database. Everything grinds to a halt because multiple transactions are stuck waiting for each other to finish.
Yeah, that's going to be a hard pass for me. Sounds like keeping your transactions short and snappy is the way to go.
You got it. The faster a transaction finishes, the better. Avoid any unnecessary delays, break those complex operations into smaller bite-sized transactions if you have to, and always be mindful of how long your transactions are taking. It has a huge impact on how responsive and reliable your app is in the long run.
Solid advice. Now, what about that other pitfall the article mentions, the one about user input? How does that tie into all this?
Yeah, that's another great point. Our article warns against directly linking user input to your transactions, and for good reason. Imagine you've got a user filling out one of those super long multi-step forms on your website, and that whole thing is wrapped up in a single transaction. What happens if they, I don't know, take a lunch break in the middle of it?
You wouldn't want to keep that transaction open and locked that whole time, right? That could bring everything to a screeching halt.
Exactly. The takeaway here is really think through how you're handling any kind of user input, when you've got transactions involved. You might have to explore different options like using AJX to handle those form submissions separately, or breaking down those larger operations into smaller, more manageable transactions.
It's all about striking that balance, right? Making sure your data stays safe and sound with those transactions, but also making sure your app is still smooth and responsive for your users.
Nailed it. Now, while those pitfalls are super important to watch out for, the article also introduces a couple of more advanced techniques for those of you who want even more control over your transactions. Nested transactions and save points, the really fun stuff.
Ooh, okay, those definitely sound next level. Would it be fair to call them like the pro gamer moves of transaction management?
Maybe. But seriously, once you've got the basics down, understanding these techniques can really take your database skills to the next level. Let's start with nested transactions.
All right, lay it on me. What are we talking about here?
Picture this. You've got a really complex operation, like processing a huge order with tons of different items. And each of those items needs its own set of database actions. With nested transactions, you can basically create these smaller, self-contained transactions, one for each item in that order, all living inside that larger order transaction.
So it's like having mini transactions within the main transaction inception or something.
Pretty much. And the really cool part is that each of those nested transactions can be committed or rolled back on its own, giving you incredibly granular control over how those changes actually get applied. If one item in that big order fails for some reason, its own little nested transaction can just roll back without messing with the other items or the overall order.
Wow, that is seriously slick. It's like having surgical precision when you're dealing with your database. So how do save points fit into all of this?
Think of save points like bookmarks within a transaction. Let's say you've got this long-running transaction going on, and you want the ability to, like, rewind back to a specific point without having to undo the whole thing.
Ah, so instead of hitting the big undo button for the entire transaction, you can just jump back to a specific checkpoint.
Exactly. Save points give you that fine-grained control, letting you gracefully handle any errors or exceptions that pop up without losing all the progress you've made within that transaction.
Okay, that's officially blown my mind. Nested transactions, save points, those tricky DDL queries, we have covered some serious ground today. But I know our listeners' heads are probably spinning right now, so maybe it's time for a quick breather. Let's take a step back and remind ourselves why we decided to go on this deep dive in the first place.
You're right. It's easy to get lost in the technical weeds sometimes, but in the end, it always comes back to understanding the why behind transactions, why they're so crucial.
Exactly. So as we start to resurface from this deep dive, what are the big takeaways we want our listeners to remember? What's the big picture here?
At its core, it all boils down to data integrity. Transactions are like the unsung heroes of building applications that are both robust and trustworthy.
They're like, what? A safety net, but for your actual code, making sure your database stays rock solid no matter what kind of crazy stuff happens.
Exactly. And, in the world of software, let's be honest, crazy stuff always happens eventually.
Ain't that the truth? But hey, at least with transactions, it's like you've got that backup plan ready to go. Keeps your data nice and tidy no matter what curveballs life throws at you.
Couldn't have said it better myself.
Yeah.
But it's bigger than just protecting your data. Understanding transactions, it actually makes you a better developer overall.
Because it kind of forces you to think ahead, right? Like, what if this breaks? What if that goes wrong? You end up writing code that's way more resilient.
Exactly. You stop being just a code monkey and become like a problem solver, someone who can build systems that actually stand the test of time.
And hey, maybe someday you'll be the one explaining all this transaction magic to some new coder, saving them from a world of database pain.
Now, before we wrap up this deep dive, there's one last thing I want to leave you with, something to chew on.
Right.
We've been laser focused on PHP and PDO today, right?
Yeah.
But this whole idea of transactions, it's everywhere. It's a fundamental part of how databases work, period.
Kind of like once you learn one programming language, it's easier to pick up others, right? The core concepts, they usually translate pretty well.
Exactly. So as you keep learning and leveling up your coding skills, don't be afraid to branch out. See how these transaction ideas show up in other databases, other languages.
Consider it your next coding adventure. And with that, I think it's time for us to emerge from the depths of PHP PDO transactions.
Hopefully you're coming back to the surface with a newfound appreciation for just how crucial this stuff is.
Remember, folks, don't just memorize the code. Understand it. Figure out the why, and watch your coding skills reach a whole new level.
Until next time, happy coding, everyone.